without any further ado, I want to introduce Deborah Duong. Am I saying that right, Deborah?
Yes.
From Rejuve AI, who's going to be talking more about generative AI and some of its interesting applications in crowdsourcing science. So I'll hand the reins to you, and you can give a much more comprehensive overview. Put your hands together. Thank you.
Okay, so today I'm going to talk to you about generative AI on the blockchain. Crowdsource science. Can you hear me?
Yeah, I'll turn you on.
Yeah. I'm the CTO of Rejuve.ai. And what is our goal? It's to get generative neural networks to make deep reals rather than deep fakes. So, as most people know, ChatGPT-4, Palm 2, and DALL-E are examples of generative neural networks, and they have amazing human-like abilities. But the reason they are successful is not that humans designed their properties. On the contrary, all humans did was just follow nature. They simulated neurons, which are in nature well, and their properties are emergent. All they did was train these neurons to predict a word in a sequence, and nature took care of the rest. So our approach to making generative neural networks realistic is to follow nature even more. We introduce principles of social science into the ensembles of generative neural networks to make them more distributed than other ensembles techniques like AgenGPT or AutoGPT, so that they point more towards truth. And we call our model the General Cooperative network. Okay, so I talked about pointing towards truth, but what is truth? What is lie, and how do those relate to neural hallucinations? For our purposes, truth is a mechanistic model that checks against reality and thus explains reality. It makes sense of the world, simplifying a complicated reality and generalizing that knowledge so that the world is predictable and thus manipulable. Okay. And so a lie is kind of similar. It's also a model. It checks in reality in some places, but not others. And because of its ability to deceive, it makes one class of persons manipulable and predictable to another class. So both of these exist in ChatGPT because both are incentivized in the culture that ChatGPT is trained on. Both truth and lies persist because they are useful to one person or another. Right? Okay, given all this, what is hallucination? Well, hallucination is a model that does not check against reality and does not exist, but could possibly. And it's not yet incentivized one way or another. So how do we get rid of them? Our approach to ending hallucination and in the process obtaining both truth and justice is blockchain with reinforcement learning to change the incentives of the AI agents. Okay, so how can the social bring about truth? Well, before truth was formalized in math and science, it evolved in culture naturally. Humans formed language through common usefulness of association, grounded in a common external reality that then pinched upon their authentic meaning. Language brings up similar sets of associations in separate minds. And interpretive social science and hermeneutics are the basics of the Steele's and Brooks theory of autonomous agents, and that is the foundation of all robotics. So this includes autonomy of perception, or that agents perceive as is beneficial for them. So in GCN, autonomy of perception closes the loop on how autonomous agents come to attribute meaning to signs. Through the co-evolution of induction, where all stakeholders find meanings in signs that are useful to them. So signs start out not having meaning, and wow, generative AI interact, they come to have meaning, as is useful to all the generative AI. So sign come to represent agent roles and what agents should perform in roles in an emergent distribution of labor that is distributed. And it's more distributed than the human design role assignments in current generative network and ensembles. So the GCN works at the level of incentives, giving generative agents incentives to solve problems in a variety of ways until they work out amongst themselves the best models that solve problems. Models that are crowdsourced from the community of science. And so individual models are put together in system biology polls to find holistic truths of science. Okay, so how do we tease out lies in science? By removing power incentives and continually testing incentives, GCN lets truth bubble up naturally, crowdsourcing the community of science. GCN is holistic, but composed of reductionistic proven facts, and those facts are put together by the GCN. So what kind of reductionistic facts? Well, we have randomized control trials. These in science are just ways of carefully checking against reality, avoiding known possible deceptive appearances like confounding, but only applicable to single or very few relationships, while the world has many more. Like you can probably have randomized controlled trials of one thing against another, but not many different combinations of things, because there's just too many possible. Human society does check against reality and retain what is learned, but in informal mode does not check single relations as well as randomized control trials. However, the neural nets of the members of society can be more holistic than randomized control trials. And in checking those groups of relations, in their holistic and meaningful cultural models, that use a kind of a constraint satisfaction to make predictions under diverse contexts. And so that's the power you see in neural network, the ability to do a constraint satisfaction against many, many different contexts together, more than we can reductionistically do them. Our aim is to find out how to use the power of the neural net, put together the reductive facts of science into a whole in systems biology, in a model, but without the power relations that have incentivized deception in our culture. Okay, so Rejuve AI aims to decentralize science. So first of all, we look at the power relations within science. And what is labor in science? Well, the labor in a data economy includes the data from one's body, like personal and healthcare data, and the data from one's mind, the intellectual property. And at Rejuve AI, AI performs the recombination of data instead of capitalists, so there's no arbitrage of data. We have liquid employment, regrouping, and reuse of people's models, and of scientists' models, and each network member contributes a small part that they themselves define, which then gets combined into a greater whole by the AI. And that AI recombines those small parts based on blindness. Blind audition, blind justice, blind randomized controlled trials. They're blind because that approach makes for a fair selection based on merit and not on bias. Okay, so how do we accomplish this blind recombination of scientist models? Okay, the General Cooperative network. As we said before, it's more decentralized and emergent than other generative ensembles. It recombines contributed data and generative models and the mixtures of experts that together solve problems related to healthcare. Generative models talk to each other, but in their own emergent language to perform multiple goals related to modeling the human body. From the individual contributions and under many challenges, mechanistic systems biology models emerge. Okay, so how did they emerge? Well, we use reinforcement learning, but we use a kind that includes both cooperation and competition. These agents interact with each other in a market and are awarded tokens. It's a simulated market, so they have many more instances to interact with each other than humans have. And they create a dynamic, multi-resolutional mechanistic simulation while they interact with each other. So in this market, they, as individual models, they are able to employ each other. And by employ, that means you delegate part of your model to someone else who's done a better job than you, maybe, but you pay them. They also form teams by employment to compete with other teams. And this is all automated. So there's both cooperation, that means you can be on the same team as another agent, and competition. You're competing with other agent teams for reward, and that reward is tokens for completing a challenge in science. Now, why would this eke out truth? Because there are many, many different challenges. And the models that together can solve the most challenges get the most tokens. So we're incentivizing solving different challenges. Agents earn simulate tokens that are related to the system they are simulating. So as they solve more challenges related to healthcare, the ones that are the best at solving those challenges are the ones that get the right explanations for the body, so that explanation will be used in one challenge, another challenge, another challenge. So they're the best models and explain the best and thus simulate the best. And so as these different simulations, as the model is more able, and the agents are more able to pick from the scientist model to make the best simulation, they pick the truer models because they're more general, the more true they are. And we said that agents employ each other. Well, there comes to be an emergent market price for models, and that price is a contribution of that model to the solution. So it becomes an emergent assignment of credit, the price a model comes to have. And an assignment of credit is important to rewarding the scientist for their labor in making a solution. And that solution could be product. And so the scientists who have contributed to the product are able to have a proportionate compensation for their contribution, according to how important they were to the solutions. Okay, so we talked about sign, and we talked about emergent languages that AIs talk to each other with. We have these AIs talk to each other. You know, if they're large language models, it can include English, but it also can include their own emergent concepts. And so why do they need emergent concepts? They need emergent concepts to find new roles that each other belongs in within a systems biology model of the human body, because we haven't discovered every piece of everything in the human body yet. And as they discover new groupings of agents, they need to have new languages that bring to mind what kind of groupings exist and their mechanisms behind the groupings. And what do I mean by emergent signs? Well, they start out arbitrary and come to have meaning as simulation goes along. And also they exist because agents induce them according to their usefulness. So their usefulness here is gaining tokens. And they induce the meaning of the sign and choose each other on the basis of the sign they display and read. They make signs and choose each other on the basis of those signs. And those signs come to mean the roles each agent has in relationship to each other. So that sign becomes to be a requirement list of what one agent wants another to perform for them. And this kind of signaling leads to self-organization, open-endedness, and emergence, so that the lower level agent wanting to, gain more tokens and solve particular problems, from that emerges an upper level sign system that that indicates what role all the agents have. And so that's what I mean by it's more emergent than designed hierarchies of generative agents that people have made in Agent GPT or Auto GPT. It's not human design, but the agents themselves decide what generative AIs will have what roles, and it's all based on signing and language. And that language itself is emergent, and so those roles are emergent. And as the roles are emergent, they're more distributed because all the agents together make that sign convey meaning, because there's lots of challenges, there's lots of choices to choose agents, and in this reinforcement learning setup, the different agents, but displaying and reading signs over time, those signs come to indicate role meanings over time. So there's an open-ended self-organization. And those signs are open-ended in that they mean different things to different agents, because they come to have meaning according to what is useful for them to perceive. And so it could be different for different agents what is useful for a sign to mean, right? And since that sign can mean different things, different agents, it's slippable, it's fuzzy, it's ambiguous. And it allows for agents to improve upon the meaning of the sign. So it means, an even better function, an even better product as time goes on. And new signs can be created to indicate new types of roles emerging in the system. Agents can act on other agents based on those roles, those signs, but not as individuals. Like, instead of an agent picking Joe, he picked someone displaying a sign that Joe might have displayed before, so that another agent can come in on a relationship and do even a better job than Joe. Signs create together. These signs create a functional space or culture, and in that space are accumulated past innovations or past ways of relating to each other in the model. And so it becomes the culture of the agents, the accumulated, associations that tell them how to organize themselves, or what has succeeded in the past in getting tokens. So it's a kind of a history, those signs, just like ChatGPT uses language as a kind of a history, but it also uses it for new, provides that history for new things. Those signs, and then those signs are implicit signs because they're like strings of zeros and ones that come to have meaning, but they can be interpreted with explicit AI into explicit lists of requirements. So what we have here is a software emulation of the social emergence of symbols from sub-symbol via symbolic interaction. Choosing each other based on the symbol. It is inspired by Smolensky's concept of the emergence of symbols from sub-symbols in neural networks. So it's similar to neural networks, but it's an interface between neural networks that keeps the history of the agent. So what is the role of signs? Well, The emergent signs indicate a group consensus. Because over time, they developed over many interactions, over many different ways that the user has perceived is beneficial for interpreters. And those group consensus are what fits together and what models fits together in this emergent simulation. So there is a possibility for specialization. Like agents might specialize in various areas. Like they might have a very developed sign that has them specialize in a particular area. In this case, a focus area like cardiology or something like that, and become very good at it. And so they have a particular sign for that particular role they have. And concepts emerge from the subsymbols in this social process. So the meaning of symbols increment towards the many stakeholders utility over time and become sort of a natural equilibrium that is specified by the emergency coordination via signaling, and that is required for the multi-resolution to mechanistically form and transcend levels. So we have the lower level seeking tokens and the upper level of the emergent science system that tells you how to make a multi-resolution simulation. Okay, so we said the upper level system, the language system they've developed, holds their history. But there's new agents coming into the simulation. And those new agents see the history and they can follow a path in vector space to optimize their income by taking on the roles that those signs indicate. But they can also, if they have neuroplasticity or they're not yet diverse, they can change those roles and improve them and improve the sign. So there's a kind of a mix of exploration and exploitation. They have the past there, but they can also explore and find ways to change the past and make a better system. Okay, so that's where you get the open and emergence through innovation. New agents provide ongoing diversity and open-ended evolution, while those who find the balance between exploitation and exploration will innovate and gain the most tokens, right? If you're too concerned, you're just going to follow the past, you're not going to be as good as an innovator. And if you innovate too much, well, you might not secure a place in the society as a known entity. So this encourages agents to reach the edge of chaos of optimal problem solving. Okay, so that's how it works. But this is all fueled by tokenomics. Scientists contribute their model to the GCN. The GCN uses reinforcement learning and multiple agents who do many trials and many different challenges and find the scientists' models that fit together the best, right? And so the GCN's challenge is to rearrange the models and even make new models that are combination models that get the best solutions to health and longevity problems. And those tend to be the truest solutions. So scientists are actually contributing, and the point is that they find the GSTN finds out which models are the best and then rewards the scientists. So we have a tokenomics that can handle this. Our tokenomics has a utility token called the reduce, where we have a network of members who contribute data. We have modelers, we have product creators, and they have transactions with each other in Reduce. And that's an already existing really utility token. Well, we have a couple more coming, and those include the data NFT, where a scientist or a health data contributor's contributions are kept track of, and the proportionate amount of their contribution is kept track of. in their data and what permissions they have given to different products for their data to be used. And the product NFT, there's one for each product. And that product NFT points back to the data NFT, which is one for each network member, and tells and finds out what proportion each one of them contributed to an end product. So that with every sale of the product, all of the people who've contributed are proportionately compensated. So we are going to have health challenge staking pools that are like the reinforcement learning of the individual challenges that in which different problems are presented, and those who have the best model that solves a different health challenge will win the staking challenge, and they will have coupons so that their data, that their product NFT can be purchased by other people, up to half of which, they can so often get money now instead of waiting until a product is released later. So this is all supported with a tokenomics system for scientific justice. And that's all I have.
Thank you so much.